Hello and good day, geometry. I told you last night to do your wrist exercises, ice it down a little bit, get ready for today because it's one of your heavier note-taking objectives. You'll notice that all of these postulates have key points down the side here. A postulate is basically an accepted math property that you can use to argue for or against something. So these should all go on kind of your postulate and theorem list. A theorem is like the most powerful. That's something that has been proven for all cases. That it's been mathematically proven. It's ironclad. A postulate is kind of the next level down. They're almost like a duh type of thing. And you'll see what I mean when we start to talk about them here. You got introduced to them when we talked about the SAP, right? The segment addition postulate, where that basically said that two parts of a segment will add to equal the whole thing, right? 3 plus 5 is 8. Well, duh, right? And so they're kind of more obvious things, but they are all important. These don't have special names like the SAP does. That's just postulate 5, postulate 6, postulate 7. So they're more properties you need to know, and you can use them when we start to use proofs. Unfortunately, they do not have catchy names. They're just numbers. But I did make a PowerPoint, so there's that. I don't think it's nearly as cool. It's not. I don't think it's nearly as cool as the last one, but at least it's something. It means I don't have to write them down myself. That's what that means. So, let me start this. Thomas, warning for you. It's my time now. Here's postulate number 5. We'll move the snowflake out of the way. Through any 2 points, there exists exactly one line. I will write on this as we go. This is number 5. So I will give you the verbal of it here, and then I'll also draw you a picture. If you want to draw the picture kind of small on your page, or maybe the back side of the next page or something, just you have it, you certainly can. But through any 2 points, there exists exactly one line. Okay? Meaning that if I've got a point here and a point here, I can connect those points with a line one way. Like that. That's what this postulate says. Okay? And it doesn't matter where that point B is. If I've got a point A here and a point B up here, that's not horizontal from it, I can still connect those points exactly one way with one line. Duh, right? But it's something that you can use in a proof. Yes, Blake?
Can a line be curved?
A line, by definition, in geometry cannot be curved. We oftentimes call, curved things lines, but in the geometric sense, like a segment, it's got to be straight. That's why a circle is not a polygon. It doesn't have straight sides. Okay. Who's riveted and excited to see postulate number 6? Thank you. Any more questions on postulate 5 before we go on? Okay. Number 6. A line contains at least 2 points. Okay. This is kind of the not quite the converse. It's not an if-then statement. It's kind of the opposite of what we had for number 5. Number 6. A line contains at least 2 points. So if you've got a line, you know that it must be connecting at least 2 points, A and B. Could there be more than 2 points on a line?
Yeah.
Certainly. We could have a point C over here, a point D over here, right? But every line has at least 2. Fun stuff. Questions? Okay. Postulate number 7.
Woo-hoo.
Yeah, right. If 2 lines intersect, then their intersection is exactly 1 point. Okay? So we've got 2 lines that intersect. What this postulate is saying is that they can only intersect in one place, this spot. Right? One line is not going to curve back around and intersect it again like a parabola would, right? They have one intersection point. Questions? Okay? No? All right. Number 8. Through any 3 non-collinear points, there exists exactly one plane. So now we're going from lines to planes. And remember, we haven't talked about planes nearly as much as we have about lines. What's a real-life example of a plane? A geometric plane. Or a plane is just like a space. It's an area. Your tabletop is like a plane. You know, right now, a lot of you have a pencil pouch and your binder and an extra pencil, a computer sitting on the plane of your desk. Okay? It's basically a flat surface. And it says through any 3 non-collinear points, there has to be a plane, because I'll use this point that keeps just popping up here. If you've got a point there and a point here, what can we make between any 2 points? A line. But if you add a third non-collinear point, meaning not in the same line as the first 2, you can't make a line connecting those 3 points. They're non-collinear, not lineable. Okay? So what that means is that they all share a space. And that space is typically drawn in a quadrilateral shape, kind of like that. It just represents an area, a flat surface, an area. Okay? And through any 3 non-collinear points, there exists exactly one. Questions on that? Okay. Number 9. Anyone got the picture down? You're all set? All good? Okay. Number 9. A plane contains at least 3 non-collinear points. So again, kind of like, not quite the converse, but the reciprocal of number 8. If you have a plane, right, you would not draw a plane around just 2 points. If you only had 2 points, you know you can make a line, so you just make it a line. But with 3 non-collinear points, that's where you've got the plane. Could there be more than 3 points? Yes. Right? You can have a point D here. In fact, you can even have a point that is collinear with 2 other points. You know, let's make point E collinear with A, E, and B. But because we have C and D there also, which are not collinear, around those 5 points, there's still a plane. Okay, so all these other geometric pieces, lines, segments, rays, can exist within a plane, but a plane exists when you've got those non-collinear parts as well. Questions on this one? All right, 2 more. Number 10. If 2 points lie in a plane, then the line containing them lies in the plane. We kind of drew an example of this one for number 9, actually, also, where you've got 2 points within a plane. We do need a third point up there that's non-collinear. Well, let's just look at points B and C here. Okay, 2 points in a plane. We can make a line between B and C. That line is in the plane as well. If you have your desktop and those of you that have a pencil sitting on it, that's like a line or a segment contained within the plane. Right? It's not going through the plane, it's resting on it, so to speak. Questions on this one? Okay, number 11. If 2 planes intersect, then their intersection is a line. And this one is where my art skills deteriorate drastically. Essentially what we're saying here is I'm going to use pieces of paper as a visual example. This is really helpful on the recording, but if you've got a plane, which is like a flat sheet of paper, and a second plane that intersects it, right? Where they intersect is going to be a line. Everyone see that there? Okay? Where they intersect is going to be a line. It'd be better if hold on, let me really be an A+ teacher here. And You don't see a pair of scissors lying around anywhere?
There's the ones you took from Drew.
The ones I took from Drew, where'd I put them? Probably in the evidence chest. I have a pair of scissors. Drake, thank you. So if you've got I'm going to cut one of these pieces of paper here. So like that, okay? So we got a plane here, right? Got a second plane here. If these planes were to intersect, woo, look at that, right? Two intersecting planes. Where they intersect is a line, right? This will, isn't that good?
No, it's curved.
Yeah, just okay. Huh? So drawing that, like I said, my art skills, it looks you've got like half of a plane visible, and then you've got the intersecting part dotted, and this is gonna be like behind the second plane, and you've got another one coming through, kind of like
Just draw a box with
like this, and then this is like behind. Does that look? That doesn't look right. This should.
I don't
Is that-
understand.
Just. No.
No.
You can't.
Yes.
Okay. Can anyone draw better? Anyone?
Caleb.
I just draw them.
No. So anyway, but that's the gist of it, right? Where these two planes intersect, like with the paper example, where those two papers kind of, this is a line, okay? Whereas two lines intersect at one point, two planes, because they're both flat surfaces, intersect in a line. Like,
You should draw the two different pieces of paper with different colors.
Yeah.
I'm not good
Oh, no.
at art.
You have.
You don't have to be good at art. It just make it so that
The last time I took an art class, you know what my grade was?
6.
No, sorry, my letter grade, not my grade number. I got a U. Do you know what U stands for? Unsatisfactory. I was an unsatisfactory artist. That's how, yeah. So, this is probably why. Okay, questions on postulates 5 through 11? Yes. Well, there are more, obviously, but that's all we're going to talk about today. Yeah, great. Oh, yeah, catch. Would not be safe. There you are. Okay, so back to the binder sheet itself. Let's take a look. Let's see, we're going to blank that. We're going to close out of this. We're not going to save my drawing. We're going to come back here. Okay, so Joe, Caleb? Yes, thank you. Joe? It says, think back to algebra. In which concepts were you using postulate 5 and postulate 7? What was postulate 5 again?
Oh, we have a PowerPoint for it. Why don't you go there?
I want you to tell me. Peter.
Through any 2 points, there exists exactly one line.
Okay, so through any 2 points, there exists exactly one line. And what's postulate 7? Caleb?
If two lines intersect, then their intersection is exactly 1 point.
Okay, where do we talk about lines intersecting in one spot, or there being a line between any 2 points? Where did that come up at all in algebra? Will? Slope, right? To graph a linear function, you only needed 2 points. That's why slope intercept form is such a gift. Y-intercept, the slope to find a second point. You've got it. Okay, that'd be postulate 5. You only need 2 points to graph a line. What about 7? What about 7? Where do we? This is only one objective actually, where we talked about 7. That phenomenon that through any 2 lines, that 2 lines will intersect at only 1 point. Where did we care about that? I'll give you a hint. Last year in algebra, it was CO38. You didn't memorize?
We don't actually memorize the objectives like you.
Or you don't know. Blake?
On a graph.
On a graph.
We would never know like which one's 0, 0.
Okay, so where the 2 axes intersect. But we did use this on a graph. When do we graph 2 lines and look for their intersection points? Okay, we did talk about with perpendicular lines. That wasn't where I was headed, but yes, that would be another one. That would be PO34 for those counting. It starts with an S. Blake?
Sandwich.
No. Starts with an S, ends in istem of equations.
System of
Systems.
Systems of equations, right? Remember we had the substitution method? We had the oxinoid, the elimination method. The third method was graphing. If they were in slope versus form, we would graph them, and wherever they intersected, that ordered pair was the solution. Okay? So we've been using these before. We just didn't call them. Today we're going to learn about postulate 7. You would have any idea what that is, right? Or why
Now
we
we
care.
do.
Now you do. Okay? But that's what we're using. All right. Study the diagram below. Identify which statements can be concluded based on the diagram. First one. We have 10 minutes left. Here we go. All points shown are coplanar. Are all points A, B, C, D, E, F, G, H, and J, are they all in the same plane?
Yeah.
Yes.
You forgot the.
Did I? Oh, I thought I said D. Okay, yes. What is this? P. Is that a point? What, Drake? Oh, it's the title of the plane. Remember, we can name a plane by any 3 points inside the plane. We could call this plane ABC or AHE or whatever, or it could be labeled with a letter up in the top. Okay, so that P is not a point. It's a label for the plane. G, F, and E are collinear. G, F, and E are going on the bottom here. Based on the diagram, can we conclude that G, F, and E are collinear? It looks like it. The most dangerous thing you can say in geometry.
No.
Okay, you cannot conclude. I don't think
Yes,
I caught
they are.
anybody. So on the test you just got back, Unit 1, there's that one in CO1 where we had to draw 3 collinear points, right? Every year until this year, you folks beat me. I've got someone who draws 3 points like this. How do I know they're collinear? Right? There's nothing connecting them. You don't know there's nothing in the diagram that tells you for certain that G, F, and E are on the same line because they're not connected. Okay? So it certainly looks like they are. If I had to bet my house on whether they are collinear or not, I would say yes, they are. But based on the diagram, we cannot conclude. Okay? Good. Angle AHB and angle BHD are a linear pair. So here is AHB. Here is BHD. Do those two angles make a linear pair?
Yes.
And how do you know that? What in the diagram tells you?
180 degrees.
What do you mean? I don't see the numbers 180 anywhere.
You just have to guess.
No.
A plus
Joey.
So ABH and BHD make up the first half, which is 180. And so in a linear pair is 2 angles out of.
Because they make a line,
Yeah.
right? Yeah. AHB and BHD are 2 angles that together make this line. So therefore, yes, they are a linear pair. If we didn't know that AHD was a line, then we couldn't say it. Right? Line BF and line CE do not intersect. So here is BF. Here is CE. Based on the diagram, can you conclude that they do not intersect?
Yes.
How?
They do intersect.
Because I just know.
Look at the one below it.
Doesn't look like it. Ugh.
No, look at the one below it.
How do you know they're parallel?
They're not parallel.
How do you know they're not parallel?
Because it says it's about equal. It doesn't say it's equal.
So this is not the about equal, this is the congruent sign, which means that they are the same.
Actually,
Jake?
So like BHA and I think CJH, would that be one on the other side?
Yeah.
Since
So BHA is this angle here, and CJH is that angle there?
yeah.
Okay.
Because they look to be the same.
Oh, they look to be? They look to be?
Well,
It looks like it?
and then BHD are be a linear pair. And then
Let me simplify this for you. Is there anything in the diagram that tells you that BH or BF and CE are parallel?
No.
No.
It looks pixelated.
But
No.
is there
The
anything
only
that-
way to determine how can you determine if two lines are parallel? What has to be the same?
Vertical angles.
No. What has to be the same for two lines to be parallel?
people don't understand.
They don't intersect because they have the same slope, right? We're told nothing about slope here. Okay? The geometric symbol for parallel is a little V going through the lines. If those were there, we could say they don't intersect because they are parallel, but they're not, right? What this whole objective is designed for you to do is to really get away from, oh, it looks like it. It looks like it. Trust me, folks, it's the most dangerous phrase in geometry out there. It looks like it. Does it tell you anything? No, it does not. Okay? So we can't conclude whether or not these two lines intersect. By writing no, I'm not saying they won't intersect. I'm saying we can't conclude whether they do or not. Yes.
So you pretty much this whole entire chapter, if you don't know something, you just say no.
If you can't conclude it,
Yeah, so you don't know something.
if you can't conclude it, you might be able to conclude it, but you don't know it because you didn't study your postulates and your theorems and stuff. Okay. So you can't conclude it. Angle BHA is congruent to angle CJA. Here's BHA, here's CJA. Can we conclude that those two angles are congruent? Joey?
I'm thinking no because there would be like a symbol.
Yeah. There's nothing labeled, no information given. You cannot conclude. Again, this note isn't saying they're not congruent. It's saying we cannot conclude whether they are or not. AHF and BHD are vertical angles. Here's AHF. Here's BHD.
They look like the exact same.
Are they vertical angles?
It looks like it.
Yes, it does.
Yes.
Yes.
Why can we conclude they're vertical angles? What's the definition of vertical angles? Gino.
So like, I don't know how to say this, but the two things are like congruent because they're on opposite sides of each other.
Yeah,
And then
vertical angles, another name is opposite angles, right? Those two angles are formed by the intersection of two lines. That's the definition of vertical angles. So not only do they look like they're congruent, but they are because of the definition of vertical angles, right? We have a reason for it. We have a definition, or some of the postulate, but there's got to be a reason for it. A, H, J, and D are collinear. A, H, J, and D are collinear. Yay or nay?
Yay.
Because why?
It looks on the same line.
No. Because there's a line literally connecting them, right? Maggie, turn it up. The word collinear means they're on the same line. There's a line literally connecting them. Therefore, yes.
That could just be a really like wide curve. You never know, so we have to put no.
No, I do
There's
know.
no proof.
No,
that
how?
J's
Well, how do you know?
There is
just,
proof.
It's just like the arrows.
What proves that this is a line here?
They're all on the same.
The J could be on the other line.
Geometrically, what proves
The J
that this
could
is a
be-
line?
The angle number.
What? Drake?
But it technically never ends
And how do we know that?
because there's arrows.
Right. These arrows tell us.
Ever heard of a circle?
Yes, that's why there are no arrows on a circle, right? The arrows tell us it is straight. The arrows tell us it is a line.
Okay, well then
You
that
cannot argue with geometric,
I can actually.
mathematical.
That one-
Sorry, you cannot argue intelligently about geometric or mathematical
I'm doing it
theorems
right
of
now.
properties.
That one segment could be curved. That one segment could be curved, and you can't know it. You're just saying it looks like it.
No, I'm not.
You're
I'm
it
saying
looks-
there are arrows on each end. How hard could there be?
Okay, well it curves there, and then it goes straight.
No.
Well, how do you know that? Does it look like it? H and J are. See how high
H
up
and
each
J are just
theory is
angle
above,
numbers.
J? See that? See how it curves there, and then it just goes back down like this.
Blake,
How do you know
bring
that?
some sanity back.
How do you know that A to D is in a segment, and then D and some other letter we don't know is then a
array?
How do we know
Rays
that?
and segments are also both straight.
Yeah.
Okay?
But it's segment.
Those are just 2 points.
You're saying it's a lie.
It is.
Could be a segment and rays.
It's not.
You don't know
It's
that. You were just
Arrow.
guessing.
It's arrow.
See, this is an actual question.
Yeah, but it's a segment and it's also a ray on the two ends.
I love
It's
how
the same, but those are 2 points on a.
I love how some of you who are admittedly by your own admission seeing these things for the very first time are trying to argue with. I mean, like,
Joe.
you know, it's kind of like. Well, I guess it's a microcosm. Is that the right word, Mike?
Well, see,
Of
you
what
give it
of
the pressure.
society today, right? You're told something, and people have their own, and say, no, that's not right because I think so.
I got a
It's like,
question.
No,
Yeah.
So since
Society
H and J don't have any specific points, like deciding where they are, why couldn't like that one point be BH, or why couldn't the whole plane be named HJP?
HJP?
Yeah.
Well, P's not a point.
Okay, so then how do we know that that one point that B is next to is BH?
The one point that B is next to?
Well, yeah, because the H is so no. Well, you can't. Well, you're just saying that
Because two lines intersect at exactly one point. That's one of our postulates.
Well, how do you know that? Is it,
Because it's one of the postulates.
Well, just because it looks like it doesn't mean it's true.
Finish the page, folks. No homework for the book. Have a nice night. We'll see you tomorrow.